Alright, so just some more topics about limits. Just some clarification. So I guess maybe the best way would be to do examples. So if I want to find the limit as x approaches 2 from the right, here's my function. So the limit as x approaches 2 from the right. It's approaching 2 from the right. Looks like it is 1. What if I wanted to find it approaching 2 from the left? And that would be -3. That's the y value that it's approaching. If I asked you what is the limit f of x, we'll call this f of x, as x goes to 2, you'd say does not exist, because the left hand and the right hand limit are not the same, so the limit doesn't exist. What if I asked you what is f of 2? F of 2 would be -3. So even though the function is defined there, the limit doesn't exist because there's a jump discontinuity. What if I asked you what's the limit of 3x cubed plus 10x squared minus 4x plus 1 over 7x cubed minus 8x plus 9 as x goes to infinity? Okay, so a couple ways of doing it. One way just would be to find what the end behavior model is. The end behavior model is the largest degree term on top over the largest degree term on the bottom. So 3x cubed over 7x cubed becomes 3/7. In pre-calc, we called that a horizontal asymptote. The limit of all of this as x goes to infinity is 3/7. That's what it'll approach. As it goes to negative infinity, it will also be 3/7. Another example, as x goes to infinity, of 2x plus 5 over 3x squared minus 6x plus 7. Well, the end behavior model of this would be 2x over 3x squared, which becomes 2 over 3x. And as x goes to infinity, you could plug infinity in right there, and 2 over infinity, any finite number over infinity is always going to equal 0. So the limit is 0. The limit as x goes to infinity is 0. As x goes to negative infinity, you could put negative infinity, but 2 over negative infinity is going to be 0 also. Okay? Another way to think of that is if the larger degree term, or the one that increases the most or the fastest, is on the bottom, the result will always be 0. If there's a larger degree term on top, or it grows faster, then it'll be infinity. So the end behavior model for this one would be x cubed over 2x squared, which is x over 2. And what happens to x over 2 as x goes to infinity? It goes to infinity. The larger degree term is on the top, so it goes to infinity. Yeah, I think that's all I'm going to say about that.